Okay, so let's take a look at another question from the 2023 HSC Standard 2 Maths paper. So this is question 27. So we are told the diagram shows the location of three places X, Y, and C. Now before we go any further in this, these bearing diagrams are really horrific questions. It's very, very easy to go wrong if you misread them. So we're going to immediately upon seeing that this is bearings, we're going to read this incredibly carefully. Y is on a bearing of 120 degrees and is 15 kilometers from X. C is 40 kilometers from X and lies due west of Y. P lies on the line joining C and Y and is due south of X. Okay, so we've got lots of pieces of information thrown at us all at once, and they're all drawn in that non-scale diagram. Find the distance from X to P. Okay, so for part A, we're going to draw the little triangle down the bottom here, which is a right angle triangle connecting X, P, and Y. Given that the bearing from north over here, this angle, was 120 degrees, this angle in here must be 60 degrees, because these are angles along a straight line, so they must add to 180. And this length is 15 kilometers. Because we have that length and we have that angle, if we're trying to find XP, which we'll call this distance here, XP with a bar over it, we can just use trigonometry. Just use right trig, in fact. So this is going to be cosine. This is the adjacent. This is the hypotenuse. So we have cosine of 60 is equal to XP, the distance we're after, divided by 15. This implies that XP, the distance we're after, is 15 times cosine of 60. Now this is the case because we multiply both sides by 15. Now we can put this into our calculator. You don't have to for cosine 60. If you know how to, you can evaluate that exactly, but in the standard papers usually you'll just do this with the calculator. Our calculator tells me this is 7.5. So therefore, the distance from X to P, which we might call XP bar, is 7.5, and this is in kilometers. So this is the answer to part A. Now part B asks us what is the bearing of C from X to the nearest degree. Of C from X. We're going to draw a separate diagram for this. Got to be very careful with the wording, because if we mess up the wording, we're going to find a wrong bearing, and everything is going to go wrong. So we have this, we have this, we have this here. We've just found this is 7.5. These questions often use the prior parts to do the latter parts, so we're going to add information we've just found here. This is here, this is north, so we want of C from X, so we're starting at X, and then we're going to C, that is this angle in here. So this angle is going to have three components, the 120, the 60, and then whatever angle is in this corner of this triangle. Now we know this is 40, we know its height is 7.5, so if we just draw this triangle connecting C and X, it's a right triangle. This distance is 7.5, this distance is 40, this distance, let's call it phi. We need this because the bearing of C from X is equal to 180 plus whatever this angle is. So we can use cosine. This is the adjacent. This is the hypotenuse. So we're using cosine twice in a row here. We have cosine of phi is equal to 7.5 over 40. This implies that phi is equal to arc cos of 7.5 on 40. Now we want the answer to the nearest degree, so we're just going to round this to the nearest degree straight away. This becomes shift cosine. Arc cosine, by the way, is cosine minus 1 for anyone not familiar with this notation. Cosine of minus 1, 7.5 divided by 40. This gives me, in degrees, minutes, and seconds, 79 degrees, 11 minutes. So this is 79 degrees to the nearest degree. So this implies that the bearing we're after is 180 plus 79 degrees, 180 degrees plus 79 degrees, that is 259 degrees. And this is the answer that we're after. And this is, of course, to the nearest degree. Right, we rounded in the question. You didn't have to round. You could, but you didn't have to. Certainly, if you round early on, because we're just adding to 180, it's perfectly fine. The rounding is going to be okay. If you have to do more things with the angle, don't round until right at the end. Right, in this question, it didn't matter, but sometimes it will. So now let's look at the marking. So let's change the marker color. So for part A, you get a mark for identifying an angle in triangle PXY. So identifying the 60-degree angle will get you a mark. And then the second mark, you have to provide a correct solution. So you have to get 7.5 kilometers. Now for part B, you get a mark for calculating one of the acute angles in the triangle CXP. So if we found phi, you would get 1 mark for finding phi, and then the second mark providing a correct solution. So adding it to the 180 or an equivalent merit in order to get the bearing of 259. These questions, you have to read them very carefully, because if you don't read them very carefully and you mess up the ordering, it's very hard to tell where you've gone wrong. So if you read what is the bearing of C from A as what is the bearing of, what is the bearing of C from X, if you read that as what is the bearing of C2X, then immediately you've got an answer that's far too small, right? Because you would be looking at C and you'd be calculating an angle from there. It's very easy to just skim through the question and misread that, right? So when you do bearings questions, be very careful, read the wording very slowly to make sure that you've got the words right and that you're actually answering the right question, because these are easy marks to get if you can get them, but they're easy marks to lose if you rush them.